Hello everyone. In this video, I'll be discussing some problems based on properties of determinants. First problem, if determinant of A equal to 3, where A is a square matrix of order 3, find determinant of 3A. So determinant of A equal to 3 and determinant of A is a square matrix of order 3, find determinant of 3A. Now since A is a square matrix of order 3, determinant of 3A will be 3 cube because order is 3, so that means if A is a square matrix of order n, then determinant of Ka will be k to the power n determinant of A. So this will become 3 cube determinant of A. So that is equal to 27 into 3. So the answer is 81. So this is using the property determinant of Ka equal to k to the power n into determinant of A if A is a square matrix of order n. Now to the second problem, if A and B are matrices of order 3 and determinant of A equal to 5, determinant of B equal to 3, then find determinant of 3AB. So using the same property, since A and B are matrices of order 3 and determinant of K equal to k to the power n determinant of A if A is a square matrix of order n. So here it is order 3, so 3 cube will come out, and determinant of AB equal to determinant of A into determinant of B. So using these two properties, we can write this as 3 cube into determinant of A into determinant of B. The values of determinant of A and determinant of B are already given. So it will come as 27 into 5 into 3. So the answer is 405. Now the next problem, if the determinant x plus a, p plus u, l plus f, y plus b, q plus v, m plus g, z plus c, r plus w, n plus h splits into exactly k determinants of order 3, each element of which contains only one term. So then the value of k is 8. Whether it is true or false? The answer is true. The question is, we have to split this entire determinant into k determinants of order 3, all should be of order 3, and each element of which contains only one term. That means when we split it into k determinants, there should no term should be sum of two terms. Every term should be only one term. So that means it should be using the property that if any row is sum of two terms, we can split it into two determinants. So these corresponding to the first row elements, we can split it into two determinants. Then corresponding to second row, we can split it into two determinants, and corresponding to third row, we can split it into two determinants. So the 8 determinants will be XPL, that is splitting the first row, then YQM, ZRN, then AUF, YQM, ZRN, like that. That is split. You have to take all different combinations here. So the first row has 2, second row has 2, third row has 2. So total it will be 2 into 2 into 2. Total 8 determinants will be there. Now to the next problem, using properties of determinants and without expanding, prove the following. So first one, x plus a, y plus b, z plus c. So equal to 0. This determinant we have to prove that it is equal to 0 without expanding. So without expanding, to show that it is 0, we have to show that any two columns or rows are either identical or proportional. So, and we can use the transformations. So here I have used the transformation C1 changes to C1 plus C2. If I use C1 plus C2 in this one, C1 will become x plus a, y plus b, z plus c. So x plus a, y plus b, z plus c, and ABC. Then x plus a, y plus b, z plus c. This will be equal to 0 because first and third columns are identical. So without expanding we got this as 0 because here we got C1 and C3 are identical. Now to the next problem. 2, 7, 65, 3, 8, 75, 5, 9, 86. This determinant we have to prove it as 0 without expanding. So here also we have to show that any two rows are identical or proportional. Now if we apply C1 changes to C1 plus 9C2. So that means first column will become 2 plus 9C2, that is 2 plus 63. So it will become 65, 75, 86. Now if you see that first and third column are identical here, so you can say that the determinant is 0 because first and third columns are identical. Another way of doing this is if here the elements are 60, 65, 75, 86. So another way of doing this is C3 changes to C3 minus C1. So C3 elements are 65, 75, 86. If you subtract it from C1, so it will become 63, 72, 81. Now if you compare C2 and C3, now C2 and C3 are proportional. So we can say that it's equal to 0. Here C3 is 9 times C2. So C2 and C3 are proportional. So the determinant will be equal to 0. So the next problem, 1 BC A into B plus C, 1 CA B into C plus A, 1 AB C into A plus B equal to 0. So here also we have to show that any two row or column are either equal or proportional. So if I take this as a determinant as delta, this determinant as delta, and if I expand this third column, it will become AB plus AC, BC plus BA, CA plus CB. And if I add third and C3 changes to C3 plus C2, then it will become 1 BC AB plus AC plus BC, BC plus BA plus CA, CA plus CB plus AB. Now here you can see that AB plus AC plus BC are common in third column. All the elements have common AB plus AC plus BC. So that can be taken out from third column. So when you take that out from third column, it will be AB plus AC plus BC will come out. Then first column is 1, 1, 1. Second column will be BC, CA, AB. And third column is 1, 1, 1. Now since C1 and C3 are identical here, now using the properties we can say that the value of the determinant is 0. So here itself you can say that the value is 0 by using that first and third column are proportional. First for the third columns are multiplying first column with AB plus AC plus BC. So here itself we can say that it is equal to 0 since C1 and C3 are proportional. Now to the last problem, determinant B plus C, Q plus R, Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y equal to 2 times ABC, PQR, XYZ. So how it is being done, let us see. So here first I have applied R1 changes to R1 plus R2 plus R3. So if I apply R1 changes to R1 plus R2 plus R3, then all of this will be added, that is B plus C plus C plus A plus B. So that means it will become 2 times A plus B plus C, then 2 times P plus Q plus R by adding these 3, then 2 times X plus Y plus Z by adding all the 3. So now here 2 is common. So 2 can be taken out. If you take out 2, it will become A plus B plus C, P plus Q plus R, X plus Y plus Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Now we are asked to prove that it is equal to 2 times determinant of APX, BQY, CRZ. So here we got A plus B plus C, P plus Q plus R, X plus Y plus Z. Now suppose if we subtract R2 from R1, R1 if we subtract from R2, R1 if we subtract from R2, that is R1 changes to R1 minus R2. So then A plus C will get cancelled here, P plus R will get cancelled here, x plus z will get cancelled. That means we'll be getting b q y here in the first row. By applying r1 changes to r1 minus r2, we'll be getting bqy in the first row. Now you see that these two also we have to convert it into single elements, that is it should be a and c. We have to get c and a, or a is here we should get c and here we should get a. So using this we can do it. Suppose we do r3 changes to r3 minus r1, so then b q y will get cancelled. In that case we'll get apx in the third row. So here you can see that r3 minus r1 we got apx in the third row. Now in the second row we got b here, a here. Now we are left, we have to get c. So c, to get c you can subtract r2 from r3. So if we apply r2 changes to r2 minus r3, we'll be getting c, then r, then z. A, p, x will get cancelled. Now here, now we got delta equal to 2 times determinant bqy crz apx, but we are asked to prove that it is 2 times determinant apx bqy crz. So if you interchange r1 and r3, if you interchange r1 and r3, it will become apx crz bqy. But since we are interchanging two rows, there will be a negative sign, because if you interchange using the properties, if you interchange any two rows, there will be a negative sign, that is sign of the determinant changes. Now, so here also this is not the desired answer, apx crz bqy. So now again if you interchange r2 minus r3, again applying r2 minus r3, so again the sign of the determinant changes. So already one negative sign is there, then sign of the determinant will change, one more negative sign will be there. So now 2 apx bqy crz. So now this is what we are asked to prove, 2 times apx bqy crz. Negative, two negatives are there, so it will be equal to 2 times apx bqy crz. So here we have interchanged two rows, r1 and r3, so one sign will change. Again you are interchanging two rows, again sign will change. So that's why we are getting 2 times determinant apx bqy crz. This is the desired answer. That's all in this video. I'll continue with some more problems in the next video.